Hello and welcome to our lesson on all 6 of the trig ratios we're responsible for knowing. All 6 trig ratios for which we can find exact values using the unit circle we're going to talk about today. So let's start with the ones that we know, that we have already discussed, like the sine, cosine, and tangent. So we know that these are all ratios that come from sides of a right triangle. And let's say in this particular right triangle that this is our angle that we're going to be using to reference here. We're going to call that angle theta. Remember, that's the Greek letter theta that we often use as a variable for an angle. If we wanted to know the sine of that angle, the ratio for the sine, and we can remember this too, SOHCAHTOA, if we remember this, the sine is a ratio of the opposite leg over the hypotenuse. So the opposite leg over the hypotenuse, we would say O over H. And then the cosine of an angle would be the adjacent leg, the one that's right next to that angle over the hypotenuse, so A over H. And then the tangent for that angle is, there's A over H, the tangent is O over A. It's opposite over adjacent. So opposite over adjacent. And we could fill those in with numbers and do calculations for specific triangles if we needed to, but that's the general concept, right? The 3 new trig ratios that we're going to talk about are called cosecant, secant, and cotangent. And what these 3 trig ratios are the reciprocals of the 3 that we already know. So cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then cosecant is a ratio of the hypotenuse over the opposite leg. And then secant is the reciprocal of cosine. So if cosine is the adjacent leg over the hypotenuse, then the secant would be the hypotenuse over the adjacent leg. And then cotangent is the reciprocal of tangent. So tangent's opposite over adjacent. Cotangent would be adjacent over opposite. Okay, so all we're looking at here are 3 new trig ratios, which are just the reciprocal of the 3 that we've already learned. All right, now on the unit circle, we gave our opposite side, our adjacent side, our hypotenuse some specific lengths for 30, 60, 90, 60, 30, 90, and 45, 45 for our special right triangles. Now for this particular example, I want to focus just on the 30, 60, 90, so where the reference angle is the 30 degrees. And remember, in the unit circle, we had a radius of 1, so if our hypotenuse was 1, then we knew the smaller leg would be half of that, and we would multiply by a radical 3 to get that longer leg, so that made a radical 3 over 2 here. So the sine of 30, we know, is the opposite over the hypotenuse. But when the hypotenuse is 1, dividing by 1 changes nothing. So we could say that the sine for 30 degrees would just be the 1/2. Now, cosecant is the reciprocal. So the cosecant for 30 degrees would just be 2 over 1. Okay, cosine for 30 degrees. Cosine was the adjacent over the hypotenuse, but again, dividing by a hypotenuse of 1 is not going to change that value. So the cosine was just radical 3 over 2, which means the secant is the reciprocal of that. So that would be 2 over radical 3. Now I wrote that a little off-centered on purpose because in general we don't leave our denominators irrational like this. We want to rationalize those denominators. So we could clean this one up a little bit by multiplying by a radical 3 and a radical 3, which means really we're looking at 2 radical 3 over 3 in our simplified form. Okay, but the concept is you take this one and you flip it over, make the reciprocal. Okay, now tangent is a little more tricky. So tangent, we know, is the opposite side over the adjacent side. In this case, if I make a fraction of my opposite side and my adjacent side, that takes a little bit of work, okay? In fact, more work than I want to try to squeeze into that little box. Give me 1 second here. I'm going to do this here. All right, when we do this work, and actually change my mind again, I'm going to change colors. So for tangent, when we take the opposite over the adjacent, we end up with the fraction over a fraction. So we end up with opposite 1/2 over adjacent is radical 3 over 2. Now, this is one fraction being divided by another, but we don't divide fractions, we multiply by the reciprocal. So really this is saying take 1/2 and multiply it by 2 over radical 3. In which case the 2's are going to reduce out, and so we would be left with 1 on the top and radical 3 on the bottom. So this would be 1 over radical 3. Again, that should technically be rationalized. So if we multiply by radical 3, then the tangent is going to end up being 1 radical 3 over 3. And then the cotangent is just the reciprocal. Now we have two equivalent forms here. We've got the rationalized form and the irrationalized form. We could technically take the reciprocal of either of those forms. Now, taking the reciprocal of the rationalized form would give us an irrational again. So what I would do is take the reciprocal of the original form. So if we take the reciprocal of the original form, the cotangent is going to be radical 3. Okay, so these are all things that we can derive from our unit circle. So the sine being 1/2, remember that was just the y value in the coordinate where that angle hit the unit circle. And the cosine was just the x value in the coordinate there, which means we could just take the reciprocal of our y, we could take the reciprocal of our x, and then we can take our x and divide it, our y and divide it by our x, and then take the reciprocal of that. So all of this information can come straight from the unit circle. And I just erased that. So what we need to remember is that the sine of an angle is just the y value in the coordinate where it intersects the unit circle. The cosine is the x value. The tangent then is that y value divided by that x value. And everything else is a reciprocal. So sine, its reciprocal is cosecant. I know it's a little counterintuitive. You would think cosine and cosecant, but it doesn't work that way. So sine and cosecant, those are reciprocals. So the cosecant of an angle is the reciprocal of the sine. So if sine is y, then cosecant is the reciprocal of y. And the reciprocal of cosine is secant. And so if cosine is x, then secant is going to be the reciprocal of x. And then tangent is y divided by x, which means its reciprocal cotangent will be take the x value and divide it by the y value. Okay, so if we can remember sine, cosine, tangent, we're going to flip all those over for secant, cotangent. And let's try it out. So here's a unit circle already built for you. It's going to be really handy if you can keep one of those around when you're working on these particular problems. And let's do a couple of refreshers first, okay? So first, if I said find the coordinates of where the terminal side of a 300-degree angle intersects the unit circle. Here's your 300-degree angle. Those coordinates, the whole coordinates right there. So we're looking at 1/2 and negative radical 3 over 2. Okay, those are the coordinates. Now if I said to find the exact value for the sine of 150, let me find 150 first, that's here. If I said find the exact value for the sine, we have to remember the sine is just the y value in that coordinate, and the y value in that coordinate is 1/2. So this is going to be 1/2. Okay, not so bad. The cosine for 135, or negative 135, let's find that first. So cosine of positive 135 would be here. Negative would go the same distance, the opposite direction. So negative 135 is going to be right there. And remember, that takes us to 225, and 225 is the coterminal angle to 135. 225 and 135 make 360 altogether. So first, negative 135, this is really asking you what's the cosine of positive 225. That's the same thing. 225 and negative 135 are the same angle. And when we're looking for the cosine is just the x value in that coordinate. And the x value in the coordinate is, let's see, back to 225 right here. The x value in that coordinate is negative radical 2 over 2. So we're going to say And really I should be a little more proper about this. Let me clean my work up a little bit here. So this is y. So we're going to say here that the sine of 150 degrees is equal to a half, exactly a half. Okay, and then here, let me again just be proper and clean this up. We know that cosine is the x value in our coordinate, so we're going to say here that the cosine for negative 135 or positive 225, which is the same thing, is going to be negative radical 2 over 2. Okay, let's try another one here. Next one says find the tangent of 210. So 210 is this, I need a better color. 210 is this angle right here. When we are looking for the tangent, tangent is sine over cosine, basically. It's going to be the y divided by the x. So we have to take, in this case, in 210, take this y value and divide it by this x value. So we take a negative 1/2 and divide it by negative radical 3 over 2. That's precisely what we did on the front of the notes there, the other side of the notes, but negative negative is going to make this a positive. And when I take a half and divide it by radical 3 over 2, that's the same as multiplying it by 2 over radical 3. And so we end up with 1 over radical 3, but that's rationalized and becomes radical 3 over 3. And so we're going to say, now that I have no more space here, that the tangent of 210 degrees is going to be exactly radical 3 over 3. Okay, and now I'm going to try to move my picture so I don't have to keep scrolling. And I'm going to get this, I promise. Edit. There we go. Let's move this down. So again, I can not have to scroll. Okay, so here we go. Here's my picture. Oh, you can't see it. Everything's in the way. Let me do this. How about this? Can you see it here? I had this idea in my head that is not really going how I planned. Maybe? Okay, so it hides the typing, just not the handwritten problem, so I will just jump from one side to the other here and go out of numerical order. So I'm sorry if that's going to bother you, but that's how it's going to have to work for me here. So let's look at the next one. Next one says find the exact value for the secant of 60. So 60 degrees, that's right here. And we have to remember what the secant is, okay? So secant is the reciprocal of cosine. So this is reciprocal of cosine, and the cosine is x, so it's going to be the reciprocal of x. Okay, so if we go to 60 degrees, we find the x value, and we take the reciprocal of that. So the reciprocal of 1/2 means it's just going to be 2 over 1. So we're going to say the secant of 60 degrees is 2. Okay, that wasn't so bad. Here, we want the exact value for the cotangent of 180. So the cotangent is the reciprocal of tangent, and tangent is y over x. So this is going to be x over y. Okay, reciprocal of tangent. So we're going to go to 180 degrees. 180 degrees right here, this angle, and we put the x value over the y value. So the x value is -1. We put it over the y value is 0, and 1 divided by 0 is undefined. So that means that the cotangent of 180 degrees is undefined. So the cotangent for 180 degrees is undefined. And that can happen. Okay, obviously happened there. And let's try the next one. Next one says find the exact value for the cosecant of 45. So 45 degrees is here. We want the cosecant. So cosecant is the reciprocal of sine, and sine is y. So this is the reciprocal of y. So we're going to go to the y value at 45 degrees, which is radical 2 over 2, and we take the reciprocal. So the reciprocal would be 2 over radical 2, and if we rationalize that, I know I skipped the work on the other one because we had already done it, that's going to make this 2 radical 2 over 2, and then those 2's will cancel, so it's going to be just a radical 2. So we're going to say that the cosecant of 45 degrees is exactly radical 2. Okay? And now I didn't change any colors. I'm going to have to go back and box some of these things in. Alright, now I don't know how I'm going to get this next group here without scrolling and messing up all my work. So the next one's asking us for the cosecant of negative 225. So negative 225, I'm going to have to delete this because it's not going to work. Let's go to negative 225. Okay, negative 225. So if positive 225 lands here, negative 225 goes the same distance the other direction. So negative 225 is going to have to go half and then 2 more, right? It's going to have to go halfway and then 2 more. Oops, I went too far. It's going to land us right there at 135 again because 225 and 135 are coterminal. So now I forgot what we were looking at. Negative 225. Negative 225, that is the same as the cosecant of positive 135. And the cosecant is the reciprocal of sine. Sine is y, and so this is going to be the reciprocal of y. So at 135, our y value is radical 2 over 2. So we want the reciprocal of radical 2 over 2. So the reciprocal of radical 2 over 2 is 2 over radical 2. We just did that one a minute ago, so that's going to become 2 radical 2 on the top, and then 2 on the bottom, which is just a radical 2. So we're going to say that the cosecant of negative 225 is radical 2. And now it's really bothering me. I should have changed colors because this is a big mess. I'm sorry. Hopefully you're following everything I'm doing here. It feels okay when I'm doing one problem and I look back and I'm like, eek, there's work everywhere. Almost. This is the OCD in me. I can't box some of them in and not others. We're almost done, so bear with me. I'm so sorry. Okay, 2 more. Number 8, find the exact value for the secant of 45. So 45 degrees, that's our radical 2 over 2 and each coordinate, both positive. Okay, so secant is the reciprocal of cosine, and cosine is x, so this is going to be the reciprocal of x, and x was radical 2 over 2, so again this is going to be 2 over radical 2, which is just going to rationalize to be a radical 2. So we're going to say the secant of 45 degrees is exactly radical 2. And then I got one last one here. If you want to try it out, this would be a good place for you to pause the video and give it a shot. If not, you can struggle with me here through this last one, tangent of 330 degrees. So 330 degrees, that's right here. Tangent is the sine over cosine, basically. It's going to be the y value divided by the x value. And we have done that a couple of times. The y divided by the x. Where was this? Yep. Sorry. I can't. Fingers are not scrolling. So again, tangent is y divided by x. So the y coordinate at 330 was negative 1/2. And the x coordinate was positive radical 3 over 2. We already know how this is going to simplify. We did the work a couple of times already. So it's when we have 1/2 over radical 3 over 2, we end up with radical 3 over 3. And radical 3 over 3, in this case, is going to end up being negative because we have one negative. So it's going to be a negative radical 3 over 3. And that is for the tangent of 330. So we're going to say tangent of 330 degrees equals negative radical 3 over 3. That's the exact value for the tangent of that angle. Okay, so it's not so bad. It's some memorizing to do for sure. And how do I manage? I somehow erased. Oh my goodness. I erased a ton of my work here. Okay, I'll go back and fix that. Man, maybe I just hit undo. Like, where did I erase? If you're surviving this, there it is, this whole video with me, I'm so sorry. This was negative 1/2 over radical 3 over 2. Sometimes I forget to turn my eraser off, then when I try to swipe to the other side of the page, it just deletes everything. So negative radical 3 over 3. So we're going to say the tangent of 330 is exactly negative radical 3 over 3. And no more gaps in the paper. Okay, so there we go. There it is. Just using the unit circle, possibly memorizing some information, but if you have access to it, I don't know how important it is to commit all of it to memory. If you can remember just the sine, cosine, tangent, which ones connect, I kind of have to talk myself through the problems every time like I was doing here. So try to commit something to memory. It's going to be helpful, but if you have, again, a reference sheet in front of you, it shouldn't be too terrible. The hardest part is rationalizing the denominator, so if you need any more help along the way, I think you have enough to get going on your practice, but as always, just reach out if you have some more questions. Alright guys, till next time, take care.